This is a Corsair HX1050 power supply that came out of the trash, of course. This one's, as is unusual for a trend lately, actually broken in a very particular way. I'm not certain how well it's going to show up on camera, but I saw it even before I took it apart. That PFC diode there is absolutely exploded. The case is just somewhere else. Yeah, that doesn't seem to be showing up, but one of those diodes is there, the other one's just kind of gone. So I figured we'd just try and see if we can fix this thing. If we're lucky, the diode's just gone bust, exploded, and pulled a fuse with it, and just replacing it is going to solve the issue. If there's been some surge on the grid or something, and we're not going to have any further damage. But yeah, there's a bunch of little stuff that could have gone wrong. We might have some open power resistor or something, but let's just dig through this thing and see. And here's the bad diode. Very obviously exploded. So I checked the datasheet for the other one, and it seems to be a 10ish amp, very fast diode, as you tend to find in these power factor correction circuits. And I had to dig around the junk bin and found a roughly equivalent diode. This one has a slightly lower voltage drop, so it's going to take a lot more load than the original, but I think it'll do as a test. So I figure I'll just slap that one in there and fire it up and see if it does anything. Because, yeah, if that's enough to get it working, then I don't care. Well, nothing's ever quite as easy as it seems. I measured around just cursory, and I noticed that there was a short across the PFC output caps, and indeed one of the switching transistors is entirely shorted. So these are extremely high-end devices. They're labeled the 35N60C3, and these are 650 volt rated MOSFETs at 100 milliohms on resistance, which is just insanely low. So I don't have any replacement for these in stock, so I figured one of them seems to be okay. I'll just remove the bad one and see if the power supply starts running. Yeah, it shouldn't make too much of a difference, but I haven't double checked, but they're probably just connected up in parallel. So the short disappeared when I desoldered them, so hopefully we don't have any further faults. So yeah, let's just remove that the bad transistor and put the new diode in and see if it runs. Alright, I've done as much as I'm going to do. It still measures shorted across the PFC diodes, even though I know both of them are okay. So I haven't been able to track down the issue. All the other transistors in the circuit seem to be okay, so I'm waging it's just going to be connected in parallel with a big inductor or something like that, depending on the topology of the circuit. But I can't be bothered to really troubleshoot it in depth because it's just, PC power supply. It's not a super expensive device. So I've just connected up a little test jig now. We're monitoring the 5 volt standby. Should be on this meter here, and I'm got the mains input connected up to my lab power supply, where we should be getting 150 volts when I flick the switch. So we're currently limited to 150 milliamps, so it shouldn't be explode too loudly, but it could still go up in smoke. Let's just find out. Would you look at that? We've got standby voltage. It very nicely ramped up at the current limit, and it seems to have turned on. Now the question is, that probably means the PFC circuit is either working or shorted. I should actually measure across the output caps to see if we've got a boosted voltage or just 150 volts there. But yeah, this actually looks very promising. Alright, so just measuring the highest voltage we have is just 150 volts, so it could just not be activating the PFC circuit while it's in standby mode, which I suppose might make sense. But I now just poked a little power switch into the ATX connector, so let's just see if it'll actually activate. We're monitoring the 12 volt rail right now, so this is where we are more likely to go up in smoke. I'll take the relay and the voltage dropped to 64 volts, current limiting at 300 milliamps. Let's just turn the voltage up a bit. The current, I mean. Right, we've now got a 1 amp current limit, so if this doesn't start it, something's likely to be very wrong. Yeah, it's screeching and drawing an amp at 64 volts. That's not looking very promising. Let's just do 2 amps, which is the maximum power supply will do, and then we'll just call it still failed. Here we go. Yeah, that's not looking very promising. It's not turning on at all. Well, that's odd. If I feel the inductor here, that's actually warm to the touch. So there's obviously a lot of current being passed through this inductor. That's extraordinary to warm up an inductor like that in such a short amount of time. Pretty much all the energy must be getting dissipated there. I think we might be getting somewhere with this actually. So I thought it was a bit strange when I measured these capacitors and saw that we had the same voltage that we had at the mains input. And when I measured the rectifiers of a power supply, the primary rectifier seemed to just couple straight to these two big caps. And that's not the common topology for these PFC controllers. You usually have a switching element taking pretty much unfiltered output from the rectifiers and putting it through this switching converter and then feeding a regulated stepped up voltage into these two caps. So if the PFC controller isn't working, you should really not have any voltage across these caps in most cases, and they should certainly not be connected up straight to the rectifier. So I checked the datasheet for the PFC controller. I think it's called a CM6800TX, and that was exactly the case. So I knew then that there had to be some element in this power supply which was shorting between the positive on the rectifier and the positive of these caps. And there are a few diodes around in the example schematic, and indeed down in there was a guy, just a normal 5406 600 volt 3 amp diode. This particular guy who's absolutely dead shorted. So I've now scavenged out an identical diode out of a similar power supply, and I'm going to put that in, and I'm feeling hopeful that this will actually put it into a working order, because we did see before when we tested it that it actually, the PFC controller would turn on. It would, start running, because we were getting a squeal, we were getting a considerable load on the power supply, and it makes a lot of sense that it would be squealing and making a lot of heat and noise when it's essentially just trying to boost the voltage of its own input, because that's what this shorted diode was doing. It was just connecting the output of a boost converter to the input of a boost converter, and unless you have some kind of magical machine which can boost its own input voltage in this power supply, then that's just not gonna work. So I'm now gonna pop a new diode in there, and we'll give it another go. Alright, we are probing the 12 volt rail, so let's see what happens when we give it 150 volts at an amp. It hasn't gone up in smoke yet, so let's flick the switch. No, that's a step back actually, to drop the voltage down to 10 volts now, and it was drawing the full amp, so not a good sign. Oh, hang on. Hey, there we go. 12 volts. I just kept flicking the power switch a few times and it finally came to life. It's drawing 90 milliamps at 150 volts DC. I did take the time to check all the other converters off camera, so I know we've got 5 volts and 3.3 volts as well. This is actually one of these nice power supplies which just has one giant 12 volt rail, and then it has these two little sub-converters taking 12 volts down to 5 and 3.3 volts. But all the other rails should be there as well. Let's just double check. So 3.3, yeah, 5 volts, yeah, that's great. 5 volts, and let's see, this should be 5 volt standby, and I think this is minus, no, that's, what's that going to be? Grey. That seems to be the power good signal, so we have a good ground, and that seems to be all over the place. It mightn't be too happy about being entirely unloaded though. Let's give it a slight load. And by slight load I mean a Pentium 4 with no RAM or power supply. But if this motherboard will turn on, it should be putting, you know, a few tens of watts on this power supply. So let's see how the power good signal turns now. That's better. Yeah, I'm definitely calling that a fix. So what all that remains to do now with this power supply, I think, is plugging it into a computer that actually works and seeing if it posts. Alright, I added some RAM to our test board, so I've got no idea of how much power this thing's going to draw at startup, so we might not have enough grunt in the HX1050 to actually power this thing, but let's just give it a go. It's trying. Oh, it's trying so hard. Well, it's just not quite making it. Well, let's see if we can just make it kind of start off a power supply and then just connect the CPU power and see if it'll manage to do something with a bit of delay. I don't know if the board is going to manage to post this way, but we'll find out. Alright. Drawing about 75 watts. So let's just reset this board. Yeah, it doesn't have enough grunt in the power supply. Do we dare put mains into this? Yes we do, so I'll just shove my banana plugs into the power outlet there, and when I flick this switch we'll have 230 volts coming into the power supply. All the components should work. I don't know. Let's see. No fire yet. Is it going to post? Drawing 85 watts. Hey, there we go. We've got a picture. I don't know what's more miraculous, that whole board working or the power supply working, but that's excellent. So now all I've got to do is order the correct components to put into the power supply, because the diode I put in is just incorrect and it's not going to run very long on one switching transistor, but that certainly is a fix. Excellent. So there you go, that's one unexploded Corsair HX1050, and it really wasn't too much stuff wrong with it, just 3 components. I'm a bit surprised because when you have these guys going bad, they tend to eat the switching IC as well, but it seems to have survived, and even all the driving stuff seems to have survived, so that's excellent news. I mean, this power supply is certainly worth repairing at this stage, since I don't have to do anything really super advanced to fix it. So I'm just going to go ahead and order, well, those 2 guys. They're probably going to be bloody expensive because this guy is very, very high end. 100 milliohms at 650 volts, jeez. But yeah, it's going to be worth it. I think this was like a $200 power supply when it was new. It's certainly going to come in handy somewhere. So, thank you for watching. Hope you enjoyed it. Cheerio.